This is static electricity, so we've got to look at the first part of electricity. If you're really going to understand all the ideas about electric circuits and stuff, it's really handy that you understand what's going on at a kind of atomic level. So we're going to look at how static electricity is formed, what the forces are between charges, and then we're going to look at some applications of this. They might ask you all sorts of questions just applying those principles, but we're just going to look at a couple of ideas about how static electricity is useful and one idea about how it can be dangerous. So if we start off, here's our little picture of the atom. So remember that the protons and neutrons are in the middle and the electrons are going around the outside. So that tells you hopefully that if you rub something, only the electrons, the things around the outside, can be moved. If you started rubbing the protons off the middle, then you'd end up with a different element, which would make life a very interesting place. So the key points are, if you get a question like this, that it's friction that causes the exchange of the particles that move the electrons. So only the electrons can be transferred. So two ways of charging something up are either gains the electrons off something else, which makes it negative, or it loses the electrons to something else and becomes positive. Hopefully you can see there that if one thing's gaining electrons, the other thing must be losing electrons. So if you make one object positive, the other one will become negative. So here's a simple animation just to show this. So take a balloon and a jumper. You'll notice the balloon has got lots of charges on it, but they're not shown at the moment. There's equal numbers of positive and negatives. You look at the jumper, equal numbers of positive and negatives. If I take the balloon and I rub it on the jumper, it's taken some negatives off the jumper, so the balloon has now got an overall negative charge. The jumper has got an overall positive charge. Okay, the next bit's fairly straightforward, but does cause a bit of confusion sometimes. Opposite charges attract, similar charges, that's charges which are the same as each other, repel. Okay, people think they know this because they know about magnets already, but there's a bit of confusion. Here's two positively charged objects. Okay, so if I put them together, they're going to repel. But notice, they haven't got a positive end and a negative end, so if I turn that object round, it's still going to repel. It's positive all the way along. The negative ones are negative all the way along, so it's not like a magnet with a north and south pole. It's not the same concept of magnets, so you've got to be careful to not start talking about the poles and stuff like that. You've got to talk about positive and negatively charged objects. Here's some opposite charges, so they'll attract, so a positive and negative will attract. Two negatives will repel. Okay, again, I can show this with the balloons. If I've got a balloon and I give it some negative charge, and I give another balloon, I give it some negative charge, okay, the two balloons will repel each other. But if I leave that balloon, it will attract to the jumper because the jumper's got an overall positive charge and the balloon's got an overall negative charge. So those are the basic concepts. They don't very often ask questions though, which are just about that. They usually ask you for some applications. They might ask you for something you've never seen before, but a couple of examples to try and help you think. One is getting the smoke out of power station chimneys. So what happens is here's some smoke, it's coming from the boiler. It goes up through a grid at the bottom. The grid's got negative charges, so the smoke particles become negatively charged. Up the middle of the chimney is a rod which is negatively charged. So the first thing that happens is that they repel from that, and then the second thing that happens is once they've repelled from that, they're pushed towards the edges. You charge the edge positively, so that attracts it. Notice they've built into that charges that the same repel, opposite charges attract. Then you switch the charges off the outside, all the ash falls out the chimney and you've got a nice clean chimney. Okay, the other one they like to ask about quite often is about spray painting cars. Okay, so what happens here is that if you've got an unpainted car, what you do is you charge the car up and you also charge the paint. There's a subtle thing which often people miss out here, which is, okay, we know hopefully they're going to have opposite charges so they can attract. But also, if you look at the paint coming out of the gun, when the paint comes out of the gun, the paint spreads out. That makes a nice fine spray. Why does it spread out? Well, because all of the paint droplets have got the same charge, so that makes them repel from each other. So again, notice they've found an application which is trying to get you into the idea that charges that are the same repel, opposite charges attract. All that's built into this one example. Okay, last thing then is dangers of static electricity. Here's the example they love to give you. So if you look at this guy, he's refueling this aeroplane, there's fuel whizzing through this plastic pipe. The pipe's going to build up static electricity. if he's not careful, a bit like you might have had when you get out of the car, he's going to take the fuel pipe off and he's going to get a spark that's built up from the static electricity. That could then set fire to the fuel, which obviously would be a very bad idea. So how do we stop this? Well, from here, you'll notice this wire going down here. This wire is an earthing wire. It's taken the charge off, so any charge that's building up as you're refueling the plane is being taken down, and that wire goes all the way over there to the ground somewhere. Literally, it's earthing it. It takes it into the earth. So the steps here for a kind of 5-mark answer sometimes on the question is that you can get a buildup of charge because of the friction of the fuel going through the pipe. That gives you a high voltage. The high voltage can cause a spark. The spark could blow up the fuel vapour. How do we stop that? Well, what we do is we earth the plane, i.e. we connect a wire that goes into the earth. That stops the buildup of charge, so we don't all die.